we all know that 9 times 9 is going to be 81. 81, and we have a q. Q squared is going to be just the q squared. And this will give you 1 mark. Question 3 deals with products that we get when squaring binomials. To demonstrate this and explain this, we'll do these questions. The question reads as follows. Simplify the following completely. So we're doing question 3. We'll start with 3.1. And we got given a square of x plus y. So we say this is a square because we are squaring x plus y. We are squaring that number there. So we are squaring a binomial. Remember that this expression has the term of x and the term of y. So it's 2 terms, and we call that a binomial. Now, to solve this type of a problem, or to simplify it, you would see that when we have a square here, it is the same as actually having x plus y times x plus y. This is really multiplying the x plus y twice by itself. So for example, let's say you have something like a 2 times 2. This is the same as 2 to the power 2, right? That's exactly what we're doing here. We are multiplying that number twice by itself. Now, when this number is in this form, it then looks like a product of a binomial by a binomial because I'm multiplying 2 binomials by themselves. What we've been doing in the previous question, question 2. And already we learned from question 2 that we can use the FOIL method. Where we say we multiply the first term and the first term in these 2 binomials. So x times x would give me x squared. Then we multiply the outer term. This is the outer term and the outer term on the second binomial. So now we'll have x multiplied by y, which will give us a positive xy. We then multiply the inner term and the inner term. That will give me the y multiplied by the x, which is the same as xy. Then we multiply the last terms on these 2 binomials. That is y multiplied by y. So that should give me a positive y squared. So all that spells FOIL. First term, outer term, inner term, and the last term. Now at this stage, we have the like terms here in the middle, which will give me x squared. And then here I'll have 2 of this. I have 2xy. So here is going to be 2xy. Then we have the y squared as it is. Now if we inspect this problem, that is to say, if we look at it carefully, it's like we're having the y, the x here being squared, you know, and we also have the y here at the end being squared as well. But when you look at the middle part here, it's like I'm taking these 2, multiplying it by x and multiplying it by the y. So I'm having a 2 times x times a y to get the 2yx. That proposes a fact that we can actually solve this problem differently. We can use inspection to solve this problem, which is going to be a shortcut to solving this problem. So that is to say, if I have the square of x plus y. What we can do is that we can say we square x, right? So this is simply going to be x squared. Then we multiply 2 with the x and the y. So this is to say here I'm saying 2 times x times y, and this should give me 2xy. Then that means I'm going to have plus 2xy. Then I square the y. I'm simply going to write y squared, and that is my final answer. So here we used inspection by inspection. Now, if you look at the two methods, this question really they mark it out of 1. They'll simply give you a mark for the final answer. The reason being is because we are encouraging, or there is a way of solving this which is much quicker and simple compared to actually the full method we have done here. Now question 3.2, we are given the square number of 4x minus 7y. So we have a square number of 4x minus 7y. Again, to solve this problem, you have to realize that a square number means that I'm having 4x minus 7y multiplied by itself. And from here, we already know that we can then apply the FOIL method, where we say 4x times 4x here, so that it gives me the 16x squared. We then multiply the outer term, so we say 4x times minus 7y, and that is negative 28xy. We also then multiply the inner terms, and negative 7 times negative 4 times 4x, that should give me again 28xy. Then we multiply the last terms, which is negative 7 times negative 7y times negative 7y. The 7 times 7, well, okay, the first thing is that the negative and the negative will give me a positive. Then the 7 times the 7 will give me a 49. And then the y and the y will then give me a y squared. Now here we have like terms, and these two, they actually give me a negative 56xy, and then here the last term will be 49y squared. Again, we can solve this problem by inspection. If I were to rewrite this problem here, the simplest way to solve this problem would be taking the 4x and squaring it, so that this gives me a 16x squared. Then taking the 2, multiplying it with a 4 and multiplying it with a negative 7. So we're saying here 2 times 4x times negative 7y. And this will give me 2 times 4 times 7. And that should give us the 56. But there's a negative here, because we're multiplying positive, and a negative. So we're going to have a negative. Then we have a y there. We have xy. We have xy because it's x times y. So that will give me an xy. So that here I have a negative 56xy. Then we take the negative 7 and we square it. You know, when you take a negative number and you square it, it's going to be a positive 49 and y squared. So here we're going to have a plus 49y squared. So here we used inspection. We solved this problem by inspection. Now, if you look at this question, is going to be 1 mark, even here 1 mark. So again, it's better to use inspection method than using the full method, because there's a lot of these extra 2 steps. Now we're going to move to 3.3. We are given here t to the power 4r minus 3 to the power 2. Now again, the first thing that we do here is that we take the t to the power 3 and we square it, right? So that now these two will multiply each other. Remember the laws of exponents, they say that the exponents here will multiply each other, and this would give me a t to the power 8r, right? So that means here my first term would be t to the power 8r. Then we take the 2, we multiply it by these 2 terms, so that now we're going to have 2 times t to the power 4r times negative 3. So this means I'm going to have a negative, because positive, 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 they'll give me a negative. Then I'm going to have a 2 times t, which is 2t to the power r times negative, that times that 3 is going to be a 6t to the power 4r. So this means here we are going to have a negative 6t to the power 4r. Then the last one, we're just taking the negative 3 and we're squaring it. So this is to say here we have a negative 3 squared, and this is going to be a 9. That means we're going to add here the 9. Then the question 3.4, again this question is 1 mark as well, because they just mark your final answer. Now question 4, we are given 3.4, we are given here 3.4, we are given y plus 1 over y squared. So again, with this question, we're going to say y squared, we're squaring this y here, so we're going to have a y squared. Then we take the 2 multiplied by the y and multiplied by 1 over y. So this means here I'm saying 2 times y times 1 over y. You can see here that the y and the y would cancel each other, so that I'm having a 1 here and a 1 there. So I'm having 2 times 1, which is 2, times 1, which is 2. So this means here I'm going to have a 2. And so we're going to have a plus 2 here. Then we square this number, right? 1 over y. We take the 1 over y, then we square it. So this will give me a 1, because remember the square would come here, the 2 would come here and also come here, right? So it means my denominator would be y squared. So it means here we're going to have plus y squared. The last question, which is 3.5, we are given the square number of negative 2p, negative 9q. So we're given the square number of negative 2p, negative 9q. Again, our inspection method says that we square this number, right? Negative 2 squared will give me a 4, it will be positive, and then the p squared will be, the p will be a p squared, right? Then we take 2, we multiply by negative 2, which is going to be a negative 4. We multiply by negative 9, is going to be a positive 36. But we still have PQ here, because I'm multiplying the 2, the negative 2, the 9. I'm also multiplying the P and the Q, so I still have the PQ there. Then we're going to square this whole number, right? We all know that 9 times 9 is going to be 81. 81, and we have a Q. Q squared is going to be just the Q squared. And this will give you 1 mark. So that is a method of squaring binomials. We simplify by squaring binomials.